Today we're talking about triangle similarity. We're trying to figure out what information about the sides and angles of two triangles allow us to conclude that the triangles are similar. We're going to prove that certain triangles are similar by using AA. All right. Oh my gosh. The only thing you need to write down, I want you to write down the angle-angle similarity and the postulate that goes with it, and you need to write down the triangle sum theorem. Please write down those pieces of information. Yeah. Bring back something to life. All right. So kind of the overarching thing that we're talking about is that we have several different ways that we can prove triangles are similar. This is going to be one of the more challenging things that we do in here this year. We're going to be making our way up to what we call similarity proofs. I hope at the end of the block today, I'll show you what a proof is. You can kind of get used to them. We haven't talked about triangle congruence yet, so we're going to do that after similarity. But just so we know, we have three main theorems that we're going to talk about as far as triangle similarity is concerned. The first one is angle-angle similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay. Two angles of one triangle congruent to two angles of another triangle. Triangles are similar, right? I want you to write this down as well. It's called the triangle sum theorem. It's very simple, but it's incredibly important. All angles of a triangle have a sum of 180 degrees. All angles of a triangle have a sum of 180 degrees. When I say all angles of a triangle, how many angles am I talking about? Three, thank you, Corey. Okay, the three angles of a triangle, of all triangles, have to add up to be 180. If it's 181, it's not a triangle. If it's 179, it's not a triangle. And it has to have three angles. All right. We need any clarification on that? Okay. All right, so we have to know that in order to know why our angle-angle similarity is true, because once angle A and D are congruent, and once angle B and E are congruent, the only possible result is that F and C are also congruent. Okay? That's called the third angle theorem. That will be there later. Right? Okay. Just read this. Don't even write it down. Just read it. See if it makes sense. Explain why the triangles are similar and write a similarity statement. Since AC and DC, I believe that says there are two different points in the midpoint, but they're congruent to each other, Okay. Angle B is congruent to angle E by the alternate interior angle theorem. Okay. Now we don't know that yet because we haven't done transversal, but we'll get there. Okay. Here's the important part. Angle A is congruent to angle D. Angle A is congruent to angle D by the right angle congruence theorem. All that says, the right angle congruence theorem, is that all right angles are 90 degrees, and therefore all right angles are congruent. Simple as I can get with it. Okay? All right angles are 90 degrees, therefore all right angles are congruent. Right? They would be. Yeah, they would be. Okay? The vertical angles and vertical angles are the same. To start it off though, we want to see that I've got two pairs of congruent angles in two different triangles. So I can conclude, okay, therefore, a fancy way of saying I can conclude the triangle ABC is similar to triangle DEC by the angle-angle similarity theorem for postulates. Right? Today we take that big leap into logic. All right? Some of you are there. Some of you were born there. Quite nice. Some of you have the channeling theory. Okay? Don't worry. You're still a good person somewhere deep down inside. Right? But some people have to work at logic more than others. It's okay. It's not as natural for some people as it is others. Right? But think about this. What you just wrote down in your angle-angle postulate. I have two different pairs of congruent angles in two different triangles. That means that my triangles are similar. That is the point of the lesson. Okay? Yes, it may be really easy. It may seem really easy. I hope it does. Okay? But that is the point of the lesson. Of course, we have to use a little bit more work sometimes than others. Okay? This says explain why the triangles are similar and write a similarity statement. Angle A is 43 degrees. Angle F is 47 degrees. Are my triangles similar right now? Okay, I get it. I don't know, Mr. Cobb. You tell me. All right, check it out. My triangle sum theorem says that angle A plus angle B plus angle C equals how much? 180, right? Correct? Well, how much is angle A? 43 degrees. How much is angle B? 90 degrees. How much is angle C? Well, we don't know right now. Okay? It's going to end up being 47, but we don't know right now. Okay? All right? That's 43 and 90. 133 plus x equals 180. How do I solve for x? Subtract 133 from both sides. What is 180? Great. What's 180 minus 133? 47. Okay. Now all of a sudden, do I have two different pairs of, or two pairs of congruent angles in two different triangles? Oh, see, yes, this logic thing, right? Okay. All right. Is B congruent to E? Good. Is C congruent to F? Good. Yeah, they're both 47. That means they're congruent. Okay. Yay! How many angles did I need to be congruent? Two pairs of congruent angles in two different triangles. Voila. All right. Look how they write it here. By the triangle sum theorem, the measure of angle C is 47. Okay. That's all that nitty-gritty work that we just did. So angle C is congruent to angle F by definition or the right angle congruence theorem, angle B is congruent to angle E. Therefore, triangle ABC is similar to triangle BDF by the angle similarity postulate. Okay. But yeah, very good. Even more logic, right? D would have to be 43, right? Okay. Awesome. That's one example of how we can use our postulates. Here's another. Actually, here's two for the price of one. Okay. First, you have the side-side-side similarity theorem, and then you have the side-angle-side similarity theorem. You need to write down side-side-side similarity, then write down the theorem, side-angle-side similarity, and write down the theorem. For our side-side-side similarity theorem, if the three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. Okay. If the three sides of one triangle are proportional to the three sides of another triangle, then the triangles are similar. All right, we've already done that, right? Correct? Y'all remember last week we did that. That's the exact thing we did, right? We write down the side lengths. We determine if there's a similarity ratio. If the similarity ratio exists along all three sides, holy smokes, we've got similar triangles. Okay. All right, this is not a trick question, but it will get some students. How many sides must I have to create or make this particular theorem? 3, thank you, right? If I've only got 2 sides, that's not enough, okay? There is no side-side theorem. I think that trips people up because how many angles do I need? I need 2 pairs of congruent angles. So how many proportional sides? All 3, okay? Check this out, Doug. Let's say this is 2 and this is 4. Let's say this is 3 and this is 6. So far, so good, right? 1/2, 1/2, right? This is 5 and this is 8. Yeah. Okay, you got me?
What about you like there was just 2 sides?
That would just be an angle. Okay. Fine. So I gotta have that proportionality. Also, I gotta have side angle side, or I can use side angle side similarity. Now, there's a key word in here. If 2 sides of one triangle are proportional to 2 sides of another triangle, and their included angles are congruent, then the triangles are similar. If 2 of the angles are congruent, I use the angle-angle similarity theorem. Okay? If I've got 2 sets of congruent angles. In this situation, though, I've got 2 proportional sides and their included angle. When it says included angle, it means the angle between them, the angle that they share. Look at their example. You see how AB and CB form angle B, right? Correct? That means that in this example, if AB is proportional to DE and CB is proportional to FE and angle B is congruent to angle E, then I can use side angle side. Okay? We'll talk about what we can't use in just a little bit. Any questions about what an included angle is? All right, we'll double check on that just a little bit. If you need more time, I'll come back later. I'm gonna move on for now. Let's verify that these triangles are similar. Okay, I've done all the work. You don't have to write this down. Please just watch. Just watch. Oh. All right. I'm trying to determine if triangle PQR and triangle STU are similar triangles. Right? I have been given 3 side lengths. Chief class, which particular theorem do you think I should try and prove? Side, side, side. Okay, so how do I do that? I'll take the length of PQ, which is 3, and set it over the length of ST, which is 4.5, and it would simplify to 2/3. Why did I pick PQ and ST? Well, I did it because it's the first 2 sets of letters that I see. Okay. Make it easy. And then I move on to the second and third letters. U and R, and T and U. Okay. U to R is 3, T to U is 4.5. Perfect. I've just done that math, right? 3 over 4.5 would give me a ratio of 2/3. Finally, I'll get to PR, and SU. 2 over 3. Holy smokes! I've got a similar ratio of 2/3 between these 2 triangles. Okay, similarity ratio is 2/3. I've got 3 sets of proportional sides. Do I have similar triangles? How do I have similar triangles? By the side, side, side similarity postulate. Okay, that's what we're doing today. That's what we're trying to prove. Right? That's the step involved. Now, I said I'd make it harder or interesting, so I will. Okay, what if I told you, what if the problem looked like this? What if we take this out? And we take this out. Okay? Right? What if the problem looked like that and there was no other information? Yes, Heather. Do I have enough information to prove that these triangles are similar? I have no angles and I have 2 sets of sides. We do a side-side similarity. Do I have an angle? If I'm not given an angle, then I don't have enough information. Okay, you need more information. They'll ask you that question on the EOC, and you say need more information. Yes, ma'am. Do I have an angle right now? See what I'm saying? If I don't have enough information, I have the strength and the courage to say not enough information. Now you're going to wrong. You're going to be wrong. But just okay. What if I had this? What if this was 43 and this was 43? What theorem, Douglas? Very good. Okay. Now all of a sudden I've got to do my math here. Okay. P to Q is 3. S to T is 4.5. 2/3, right? P to R is 2. S to U is 3. 2 over 3. The included angles are congruent. See what included is? Included angle. The angle between those segments, or those sides, they are congruent. I've got 2 proportional sides and an included angle that is congruent in 2 different triangles. Yes, I have similar triangles by side, angle, side, similarity. But there's more. because somebody out there will make this mistake. I don't know who you are. This angle is 40-30. Okay? That angle is 40-30. I'll tell you what, I'll make it really easy. And this angle is 43. Okay? I'm not giving any other information except this. Right? Tell me what this is. Tell me what this is. What is angle R? Is it an angle or a side? That's not a good question. Yeah, it's an angle. Okay. What is R to P? An angle or a side? What is P to Q? An angle or a side? All right. Just so we're clear on things, guys. Okay? Just so we're clear on things, because this will happen. This is what happens when you try and make something that is not included similar. Right? This is what you do to yourself. Okay? Hear me? This is an excluded angle. Right? Now, you get to lots of things in life. You can chase it, you can grow it, you can work it, you can give it, you can take it, you can buy it, you can sell it. All right? That's up to y'all. I'll let you make your own decisions. Do not bring that into my classroom and use that as similarity or congruence. Okay? Don't do it. Sure. Well, it will not give you similarity and it will not give you congruence. So as far as I'm concerned, you can leave it outside. I don't know. You got it. You do you. Okay. Last time I checked, that wasn't one of the things that I told you that proves similarity, and it's not going to be. So do you see how? Don't see how this is not an included angle between the two sides, right? All right. This is what would happen to you if you don't understand that included. How important is it to be included? And yes, I know it's kind of funny to say it and stop and look at it because it's morning on Tuesday you're here. All right, but check it out. If you just tell yourself angle, side, you'll instinctively always remember, no, that's not similarity, that's not congruent. Okay? If you tell yourself side, angle, side, it'll be okay. All right? The reverse is true as well. Side, angle, no man. All right? Okay? Side, angle, side. Don't be an angle, side. All right? You choose what to do with it. Okay? Don't bring it in here. All right. We got a few properties we need to write down. Here's the part that you need to write down. Reflexive property. You need to write down this part. The reflexive property of similarity. Triangle ABC is similar to triangle ABC. Genius, Rouse. You're a genius. Well, thank you. All right. Right. The reflexive property. Check out my blue triangle with A, B, and C. Check out my red triangle with A, B, and C. They share side lengths, they share angles, hot dog, very similar. Okay? A, B, and C are a similar triangle. The blue one and the red one. I can have two different triangles that fit in the same particular sides, fitted with the same angles, fit with similar proportional sides, they're similar. Okay? My symmetric property. I'll move one of my triangles down. Okay, you're going down. just become DEF. Okay. DEF, check it out, y'all. If I tell you this, are those two triangles similar? Yes or no? Through what theorem? For similarity and possibility. Angle, angle. Okay? The angle, angle theorem. All right? Well, this means, understand, this is what the symmetric property says. Hopefully, this is not something new. I hope that you've heard these terms before. Okay? Here's what the symmetric property says. Triangle ABC is similar to triangle DEF, and therefore, triangle DEF is similar to triangle ABC. Okay? It's symmetric. It chases each other, like a dog chasing its tail, right? Or the tail chasing the dog. Okay? All right? One more thing called the transitive property of similarity. It's important as well. Make sure you write it down. Let's say I take ABC, DEF, and I add one more to it. We'll go right here, X, Y, Z. Okay? Check out the transitive property. Lucas, listen. If ABC is similar to DEF, and DEF is similar to X, Y, Z, then the third part, ABC, is similar to X, Y, Z. Okay? They're all similar. If I'm just going to say it like this. Typically, transitive property, you look for something in threes. Okay? That means if A, then B, if B, then C, therefore if C, then A. Right? Again, all those logical. Okay? All those logical things. It's like triplets. You know, triplets are born at the same time. Right? So, let's say we have three triplets. Huey, Dewey, and Louie. Okay? Huey shares a birthday with Dewey. Dewey shares a birthday with Louie. So therefore, Louie shares a birthday with Huey. Okay? Why am I getting blank stares? That's great. Yeah, what's up? Huey, Dewey, and Louie. I mean, sure. Yeah. Yes. Nope, you lost your chance. All right. Check it out. These are the types of things that we want to be able to do. Okay, I'm going to give you a glimpse. I told you I'd show you a proof. I promise. Given that 3 times UT equals 5 times RT, that makes no sense, and 3 times DT equals 5 times ST, prove that triangle UBT is similar to triangle RST. I can say right now, you just 3 times UT and 5 times RT, 3 times CT, and 5 times ST. That would be about how you set it up. I don't like this problem. I don't want you to do this problem, but I want you to see what the end goal is. Okay? We get here tomorrow in our lesson. This is the end goal. This is a proof. This is what you'll be doing. This is called a proof. Geometric proof. Okay? Right? I was given that 3 times UT equals 5 RT. I have to set up my proportional, and then you explain out here what to do. Divide both sides by 3 RT. Then you get this. After you cross multiply, you get 3B. Oh, sorry. There's another given. 3BT equals 5ST. 5 both sides by 3ST. Your vertical angle theorem would prove that. You have side angle sides. Okay. I don't like this example. I think it's really, really tough. It's a hard example to see. There'll be better ones tomorrow. But understand, this is what we're getting to in the end. Okay? Not today, just soon. Just soon. Okay. All right, that's all I've got for today. I'll give you your break. We'll get started with the last one.